Oh, that was underwhelming. Hang on, everybody. Let me get this banner out of the way. Sorry about that, everybody. Man, those banners are heavy. Sometimes I can't move them very quickly. Oh, I'm just kidding. But how are you, everyone? It's great. It's great to be speaking with you. Looks like we have quite a few people for today's Earth Engine stream. So I'm really excited to get going. Let's turn the background music up a little bit more. I like to have it in the background. Why not, right? Everybody, let me know if you have trouble hearing me. I have my microphone here, and I try my best to make the stream as comfortable to your ears as possible. So yeah, definitely let me know if you're having any trouble with that. Hello, we have some folks in the chat. Haru Melody, great to see you. And good to see you, Insha Sheikh, and Husian Shu, and Brittany. Good to meet you. Hi there. And of course, Paul from last stream did an amazing job on that one. What a great time. It was so enjoyable to see that stream and see all the positive energy that you all were bringing there and that Paul was bringing. So excellent work. Okay, everybody. Well, we're going to be speaking about Earth Engine today. And let me kind of pull up Earth Engine screen so that we can all see kind of what this is. We're going to be using their Earth Engine API today. It is API week. So let's look and see what this stuff is, in case you've never used this before or encountered it. But while we're working on Earth Engine, we're going to fill out a few forms. I know everybody comes to Global Hack Week because they love to fill out forms. That's a joke, of course. Nobody wants to fill out forms, but we got to do it. So the first form I have for you all is about registering for the event. And this one is actually really important because it's going to get you points for your guild for attending. And it's also going to let us know what kinds of content folks are interested in. If we see a lot of registrations, that helps us understand what folks are wanting to see for Global Hack Week. So you can go ahead and register there. Another link that I want to send you all is this link that I made myself. It's a form, a Google form. And I sent it in the chat so that you all can access that Google form and try it for yourself. See if it works, first of all. And it's just collecting a little bit of information about you, like, are you a good JavaScript programmer? Are you comfortable with GIS, which, if you've never heard of GIS, it's Geographic Information Systems. And so if you could fill out that form, that's also going to be really helpful to me as we go through the workshop today, because it gives me an idea of really what your level is on all this stuff, so we don't move too quickly or too slowly. But yeah, where's everybody logging in from? I'm always curious to know, like, what part of the world folks are logging in from. Maybe if you could just say your time zone if you feel comfortable. Looks like we have Wombo Combo from New York. I see you a lot in our community, Wombo Combo. Great to see you coming back. And also, A Jackson. But we have some people from all over the world. India, California, Arizona, Oregon, Denver. That's great. I myself am from California, so I'm logging in from Los Angeles. But it's really great to be with all of you, and I'm glad that you made your time in the day, no matter what time zone it is for you, for our workshop today. So yeah, we're just going to wait a few moments as the responses trickle in from our survey. And before we continue, I'll just kind of, while we wait, explain a little bit of Google Earth Engine. So Google Earth Engine is basically a giant like Earth computer, if you want to think about it that way. Earth data is super, super rich. and huge. Files can be terabytes, even petabytes of data. And so you can't really download it all and do computations on your local computer. So what Google does is they put this data on Google Cloud and really allow you to do a lot with it based on Google Cloud. So, you know, there's a lot of great information here, and I wanted to point in particular to their data sets. So if you are interested in climate and weather, there's some great information about the surface temperatures from the sea, and also things like atmospheric data, like rain patterns and clouds. If you look at this giant green band, that is what we call the intertropical convergence zone in Earth, raining a lot of rain down on the tropics. That's why they're so wet. And you can see all of this stuff because of satellites that governments have put up in the sky. So Landsat is an American satellite from USGS and NASA that has been observing the Earth since 1972. So you can see a really large amount of long-term data from Landsat. And then there's also Sentinel, which is a European satellite made by European Space Agency. And this is actually much higher resolution than Landsat. It's not 30 meters. Actually, they can get down to 10-meter resolution. So there's some really great products, and all of them are available on Google Earth Engine. We're only going to cover a few today, but yeah, it's a really great piece of software. And someone says, "Wish Indigo was here. He loves GIS." Well, if you would like to send this workshop to your friends, feel free to. It's going to be recorded, so yeah, it's going to be a really great time. All right, everyone, let's take a look at those survey results that I promised you all. I'm going to make sure that I do not reveal any personal data in this. I actually don't think I have anyone's names attached to this survey, but I just want to point out a few key things. So the first question in the survey was, how's your JavaScript? And 50% of you said that you're kind of at the basic level, you know, the basics of JavaScript, but maybe you're not super comfortable with it yet. And we had a really big range. We had some folks say they're experts, but also that it's their first time. So yeah. And then the next question was, are you familiar with GIS? And a lot of you said no to this question, the majority. And then even more of you, 3/4 of you, said that you've never used Google Earth Engine before. And then finally, we had one last question, which was, what do you hope to get out of this workshop? And you know, we have, just to kind of summarize folks' answers, that, you know, we have some folks that are real GIS experts, but then we also have some folks who are just trying to learn a little more about it. All right. So hopefully this workshop will be useful to anyone, no matter what skill level you're at. But it's really going to be geared, this one, as the title suggests, 101. It's going to be geared towards beginners. Tom Wells says, "I'm an expert noob." I love that. Me too. I'm an expert noob too. I love learning new things, and I think that's something that everyone in our MLH community can agree on. All right, folks. So why don't we dive right in? And it's going to be important for you to create an account where you can use Earth Engine. So if we go back to this homepage, it's called earthengine.google.com. And I'm going to paste that into the chat. See if I can follow along with you and essentially try to do this myself. All right, so if we were to click on the right-hand side, the Get Started button in the top right corner, I'll zoom in a little bit for you. You're going to want to sign in with your Google account. And yeah, I guess this is kind of where mine stops. But once you sign in with your Google account, you're going to want to make sure that you let them know that you're not a non-commercial user. So it's really important that you do that. Let me see, actually, maybe I can log in. It might not let me though. All right, so once you continue, let me show you what it's like. So I'll share this tab instead. Yeah, you're going to want to register, and I think it's okay to just go to the code editor, go straight to the code editor. And you'll notice that this service is free for academic and research use, and we're using this for educational purposes. So we do not have to pay for Earth Engine, unlike some other folks who may have to pay. Once you're in the code editor, I'm going to actually send you all a link to a project that I've kind of started for us. And let me send that. I'm going to try and make a short link because it's kind of a long URL. And I don't really like it when people give me long URLs, especially in a workshop setting. All right, let's see if this tiny URL works. Doesn't everybody love tiny URLs? They make the whole world easier. All right, I think I got it working. So we will go ahead and use that tiny URL. Hello, IMS. Really good to see you. It's awesome to be here. And Mirab says, do not use Bitly. Curious, why not? I did not use Bitly, but yeah, I'm curious if there's a reason for that. I'd love to know it. But anyway, once you go to that website, you should be able to see the following page. I'm going to share it with you. All right. Oh, Bitly's banned. Okay. Well, let me know if you can see that tiny URL. If you can't, I'll send the actual link so that you can see it no matter where you are. So one more comment says it's asking if I want to make a new project or use an existing project. And if you are getting this error, it's totally okay to make a new project. And then you can you can go follow this link, and I think it will let you in. Yeah, so it's totally okay to make a new project. And on the left-hand side of your screen, what you should be able to see, let's see if I can make this a little bit bigger for all of you. That didn't really help. Right? Maybe this will help. Yeah, now you all can see a little better now. And if you should go non-commercial, yes. So make sure you're clicking on non-commercial. If you make a new project, then you should just be able to click on that tiny URL link, and all these files will pop up in your Earth Engine. But if you follow all those steps, it should lead you here to the Earth Engine. And while folks are getting accommodated with that, I'm going to go ahead and point out some things to you while we're doing that. Let me get my guide, actually. I have a little guide. Awesome. So yeah, while we're going through this, let me just point out a few things. In the left side panel here, you have what they call your scripts. And so these are just JavaScript files that are stored in your Earth Engine. And there's also docs. This is for the API documentation. So you remember, this April, we are having Global Hack Week APIs. So that's why I chose Earth Engine, because it's a really great API. And these are all of the documentation. So let's look at one example. We can look at image, for example. And there's this image object that we can use. This image function that would not normally be available to us as local computer users, because we don't have enough resources to kind of retrieve these images so quickly from the engine, from Google Cloud. But with Google Earth Engine, we're able to do it. And we have things like the geometry tool, which is used for drawing rectangles and other shapes around Earth to sort of organize our data, specify what we want to look at. And this assets is just sort of any cloud assets that you might want for making a mask over your data, or adding in a new map or something like that. But we won't be focusing on assets for this time. Over here, these are what we call our geometry tools. So we can move this map. We actually have a Google map right over here. And so you can just kind of look around and see what's going on. Maybe we can look at Topeka. I one time had to stay at a hotel in Topeka. So if we want to draw a box around Topeka, we could. And see what the temperature is like there, for example. All right, let's exit out of there and check our geometry box. And let's look at now the code editor. So this code editor is where we can put our JavaScript, and we'll be looking at that soon as like a way to run and even a way to get links. So if you ever want to troubleshoot something with me, just click get link and paste it in the chat, and I'll take a look at your code. Then on the right-hand side here, we have our console, and this is what's going to output into Earth Engine any of the results from our JavaScript. So there's some of you who said that you've never actually used JavaScript before. So I'm glad that you're going to be trying for us for the first time with Earth Engine, because it's a really great way to learn. And welcome, Indigo Wizard. Great to see you. And as Indigo Wizard mentioned, that we do have Google Earth Engine in Python as well. So if you're interested in using Python, you have that option as well, even though this workshop will be in JavaScript. And yeah, GEE, Google Earth Engine, is great for doing exactly this. Basically, anything that would take a really long time on your computer, you can speed that up by using Google's software. Hi, everybody. And this search bar is really great too. You can use this to kind of browse the data. And like I said, we have like Landsat, which should um, give us something. Yeah. So these are all of our Landsat satellites information. And, a lot of this is kind of hard to understand right now, but we'll dive into it as we go through the workshop, exactly what all of that stuff means and why we would have so many versions of Landsat. But before we continue, let's go over some basic JavaScript. So you'll click on this 00 file, and this is going to be the first file in our project. And it's actually just getting us used to JavaScript syntax. So I know that some of you are familiar with just the basics of JavaScript or need a refresher. So we'll go ahead and do that now for a few minutes. And of course, the first thing that anyone would ever do in a programming language is the hello world function. And we can do that in in JavaScript by typing print hello world and a semicolon. So the semicolon is pretty important in JavaScript. But let's click run to see what happens. Get our hello world output, and these double slashes are actually creating comments. So anything that's in the double slashes won't be visible to the code compiler. And for that reason, I tried to comment out everything else below. But let's continue on and look at some other things. So we have variables in JavaScript as well. And to use a variable, you type var keyword and then a space and the variable name, and then an equal sign to assign the variable, kind of declare it to be equal to this particular value. So when we run that, nothing actually prints out to the console, but now the answer variable is stored in JavaScript as 42. This next line is just showing you that you can also store strings. And string objects can they can not only take on single quotes to show that they are strings of characters, but also double quotes. So that's totally okay if you do. It won't give any errors. And if a statement does not end in a semicolon, the editor will kind of give you a complaint. So make sure to run all of your statements with semicolon. And print statements are what actually prints to the console. So this is what we used in our hello world example. We printed out a string called hello world. But in this case, we're going to just print out this longer string. And when we click run, it prints after hello world. We also have a list function in JavaScript. So if you want to make a list of objects like eggplant, apple, and wheat, you can do that with a bracket. So you'll just put two hard brackets around this and separate the values by commas, and that'll get you to a list. And to print out a particular element of the list, you can use this index feature. So when you click print my list and then 0, it'll get you to eggplant. And a lot of folks get confused about this kind of stuff because you're starting with 0, and why would you start with 0? But trust me, it's just the way computer science mostly goes. So, all right, now we'll move on and look at our dictionary objects. So dictionary objects are using curly braces, not hard braces, and they associate keys with values in these things we call key value pairs. So you have the food key for this dictionary, and the food is bread. And so then we could also say color is red. And so the keys are these food, color, number, and the values are bread string, red string, and the answer, which I don't know if any of you remember, but yes, 42, it's the answer. I don't know if any of you have been interested in reading that book, but yes. And Ajax says it's easy to do time-lapse video with GEE. I've seen that done before. It's really, really cool. I've never actually done it though. Maybe we can try a time-lapse video for our third part of this workshop. That could be really cool. Okay, so now we're going to move on and try printing out some dictionaries. So we can print out a dictionary value using either this feature, so using the hard brackets and the key string, or we can use dot notation to get the same result. So we just type mydict.color and let's run this. We should see, well, think for yourself what we might see when we run this. Okay, so we saw eggplant from the last one, but then we see red as the value that's returned from the key value pair. And that's exactly what we would expect from our dictionary. Okay. And then functions can be defined as a way to reuse code. And so here's a function that we have written in JavaScript. And it starts out with a var, V-A-R, just like our variables do. And my hello function is going to be the name of that function. So that's kind of how JavaScript will feature that. And then we use the function keyword. And this parenthesis indicates the parameters that the function accepts. And so this function that we're writing only accepts one parameter, and the name of it is string. So we can now use that parameter anywhere in the function. And that's kind of the beauty of functions, because we only have to write this string parameter once, and then it can be used as many times as we want inside the function. So in line 39, we have return keyword, and that's going to return whatever value we want in place of the function. And so it's going to return this hello string, this string parameter, and then an exclamation point. So think to yourself, what might print out when we write my hello function and then world. Okay, let's try it. And we get hello world with an exclamation point. So that's basically how this JavaScript thing works. I know this is super fast introduction to JavaScript, but if you want me to review any section, or if you get stuck as we're going along, please feel free to reach out in the chat. But I also noticed that most of you said that you at least have a good basic understanding of JavaScript. So I didn't want to spend too much time on this sort of foundational stuff. All right. So any questions at this time, or should we move on to the next section? Yeah, and a few things while we're waiting for any questions. You can click this save button, and that will save your information. And you can also click this get link button. So if you click that, it will give others access to this code snapshot. And so now you all can use that code snapshot. And if you want to send me a code snapshot, please feel free to do that. Those are the three main buttons: save, run, and get link. That's kind of interesting. All right, everybody, let's move on to client versus server. So I don't know if a lot of you are familiar with this, but there are basically two different sides to an application. There's the client side and the server side. So let's look at this first few lines, and that's going to be something that exists in the browser on your local machine. In other words, on the client side. So we'll just comment out all this stuff and print this out. And in fact, we get this list 0, 1, 2, 3 that prints in the browser on our side. We can see that. And now we're going to look at a handle for some object in the cloud. And this is actually a way to access something from the server side. And you can know that it's server side whenever we use this EE keyword, because that stands for the Earth Engine and the API that we're using. So these functions are available again in the documentation. When you click on docs, you can see the list function. Okay, and so we can pass a list through the Earth Engine and print it out and see what the result is. So let's run that. And you might be thinking, hey, this looks pretty much exactly the same as what we got from the client side. So what's the difference? And the real difference is that, we're using the Earth Engine list method. So this information is coming from our computer back to Earth Engine and then back to us. So it's kind of taking a round trip. Whereas this client side thing is just staying right in the browser. Okay, we have another list here. So we could use the list method to create a sequence and do the same list. If we look at this, client-side objects are mutable. Does anybody know what the word mutable means? This is kind of a computer science-y question. So it's all good if you've never heard of the word mutable or immutable. But yeah, Enthusiastic Alien has it right. A mutable object can be changed. And in fact, an immutable object cannot change, right? So yeah, we're going to be testing that right now. Client-side objects are mutable, so let's run this. When we print out this list with a push, which pushes a new element to the end of the list, 4 in this case, it actually updates the list. But if we try to do that on our server list, oops, don't want to delete it. Unfortunately, we get an error, and it tells us that push is not a function for the server list. So the server list is something that's server side, and so it's immutable. And there's good reason for that. We don't want anyone to just be able to mess with the satellite data. And I definitely don't want you to think that you're going to somehow mess up Google Earth Engine if you make an error in your code. So it's a really good thing, actually, that our objects are immutable. Okay, let's try the next one. So this is going to be the add method. And you can use the docs tab over here to check out the add method. But basically, the idea is that we're going to capture this new object that we're creating in a new variable on the client side. So if we wanted to add something to our server list, we can, but we have to save it locally. So let's try it. And that actually worked. It did not give us an error. So it's really important to know this difference between server and client side, because it's going to give us some very different results. And let's look at an image example now. So we can use these image objects in Earth Engine as well. And let's look at an example here. So the comment says, note that the browser calls toString on the object and then appends 42. So would you expect this to kind of work for us, to just use this add here? It won't work because this is a client-side operation. And so instead, what we want to do, see, it gives us kind of some junk information. Instead, what we want to do is use the add feature, which is going to be on the server side. And we just added that to the map. And you can see it's kind of this black boxes, but we just added it. And we can get rid of it too if we want. But this is a good way to request the value of a server object here. Remember, we want to use evaluate when we're doing this. We don't want to use something like get info because that's gonna be the server side command. So if you wanted to find this value, which is 7, we don't want to just get it. We want to evaluate this function, which we could actually just set it to n if we want. Totally fine. And we get 7. So there's a little bit of a learning curve because, once again, we're not all used to dealing with server-side objects. But if you sort of think of it as two sides of the coin, where server-side is what is happening on Google's end to host these huge images, do these complex operations, and deliver you the data that you want, then you can think of the other side of the coin as the client side, where you on your personal computer can just kind of relax and get the outputs. All right. So does anyone have any questions about that? Let's see. I'm gonna get rid of this little layer here because I don't like looking at that black layer. It makes me feel a little bit scared almost. Let's zoom into something else. We can zoom into Mexico City. Always wanted to visit Mexico City. But all right, everybody, why don't we continue on and try out the next script, which is hello images. So this is script number 2. And we're gonna visualize some image. If we click run, it should work. There it goes. So to any of you, based on the JavaScript code that we're looking at right now, do any of you have an idea as to what we're looking at on our screen? I mean, this is kind of strange looking stuff. If we uncheck these boxes, we just see a normal Google map. If we check DSM, we get this black and white object. And then DSM palletized, we add all this color in. So what's going on here? We're basically creating a new image overlay on top of our map that is containing data. And it's data particularly about elevation. So you can see that when we print out this imported image, which we're getting from a satellite record, you can see there are all these bands, and they have a lot of metadata associated with them. They have elevation values, and those elevation values can go from -480 all the way up to 8,900 meters, which is a really big range, and that's the range of elevations we see on Earth. So we can actually deal with this data by adding it as a layer to our map. And so we need to select one of these bands in particular, and we end up selecting the first one, which is the elevation value band, which is specified here, AVE. And we're telling the layer that we want it to kind of visualize within 0 and 500. So anything that is less than 0 is going to be at the lower bound, and anything that's higher than 500 is going to be at the upper bound. So when we put in DSM, you can see nothing is really any lower than the white, and nothing's any higher than the dark black. So we're losing a little bit of information there. We could always change these values if we wanted to. And in the color section, we're creating a palette of 5 different colors, which we're going to use in our parameters. So this palette is a list, as you remember from our JavaScript tutorial, with different strings in it, representing different colors. And then the elevation params is a dictionary object, which has key value pairs. So there's a minimum, a maximum, just like our previous one, except we also have a palette key value pair. So we can attribute a palette to attach a palette to our layer. And that's exactly what we see in DSM palletized. So that's why we're getting those nice colors. And it gives us a little bit more of a sense of how the elevations are changing in our data set, even if the palette choice is a little bit questionable. So anyway, Ajax says, look at Hudson Bay. Yeah, let's do it. Why not? This is in Canada. Cool. It's like a pretty high elevation place. A lot of red, a lot of green. And the other place we were looking at is Florida. Florida, I think, is going to be really low. Florida is a very low area. Yeah, look at that. Super, super blue, which is an indicator of low elevation. You can see in our palette, the two lowest elevations are black and blue. So yeah, there's also topography of the area. So that's interesting. I haven't really explored that too much, but that's definitely something you can look into with this data set. You can see we have some information about that. All right, everybody. So now we're going to look into the next section, which is going to be computations on images. And we're going to actually try and calculate some stuff, get some numbers out of this thing. And we're going to do that using the same image object, the same satellite image that we got for the first time. And we're going to particularly select the elevation band using the select method. And as we were just speaking about, there's many bands in this image, so you don't have to analyze the elevation, but we're just going to do so for the purposes of our workshop. And we can do math like adding 3, for example, to the elevation everywhere. So if we wanted to do that, why not? We can hit run and see what happens. So you just get the elevation everywhere plus 3. Not super interesting, but we can definitely do it. And we can also do relational operations on images. So this is how we relate one number to another. And we're going to say any number that's greater than 500, let's make that, let's sort of color that in. And anything that's not, we'll leave it. So when we run this, it takes a little bit of time, I think. Oh, sorry about that. I think it just needs some time. Oh, here it is. I was looking at the wrong part of the US because actually there's no high elevation there. Let's look at another area maybe. We can look at Europe now. You can see the highest elevation places are really in Southern Europe. If you look at the Northern Europe, there's not really much in the way of high elevation until you get into Sweden and Iceland. So kind of interesting to look into this stuff. And Turkey is pretty much all high elevation. So that's pretty cool. One thing that I like about GIS is you kind of have an intuition for these things. I mean, you can look at the place where you live, or if you just know a thing or two about the Earth geography, you can see if things make sense. Like, look at this, all of Tibet and the Himalayas are totally yellow. And that makes sense because we want to see that high elevation there. We would expect to see high elevation there if you kind of know about the Himalaya mountains and stuff. It's a really, really great field, I think. So let's look over here now. Looks like terrain might have deprecated since this tutorial was written. So maybe we'll just skip that portion. But yeah, folks, so maybe you can look into that if you're interested. Indigo says we can use Japan Aerospace Exploration Agency for higher resolution. That's cool. Maybe we should try that. Yeah, if anyone has the address for that satellite image, I think we're using JAXA ALOS DSM AW. And yeah, Indigo, if you have anything interesting that you'd like to share, please feel free. I get the sense you're very expert in this field, so it's so great to have you here in the stream. Thanks for joining and sharing some of your knowledge. All right, so we'll try V3 too instead of V2 or V11. See what we get. Might get something more high resolution. Who knows? Actually, maybe I'll use this junk layer. It's not letting me do that. Well, we'll move on for now. Maybe it's not quite as simple as just changing out the URIs, but why don't we move on to the next notebook, which is going to be spatial reduction. So for those of you who might not be familiar, spatial reduction is a way that we can reduce so many dimensions of information into maybe, let's say, one number or a set of numbers. So we have our imported satellite image, and we have a geometry, which is this polygon here. So let's actually look at this geometry real quick. When we run this, still not letting me use this terrain object. I wonder if anyone knows the troubleshoot for that. Yeah, who knows? But yeah, these are the coordinates of the polygon, and we're going to try and compute the elevation over that region. I'm afraid we might not be able to use this terrain feature, which I was hoping to use, but it seems like we might not be able to, unfortunately. Let's get rid of this here. Bummer. There's always an part of the workshop that gets broken, unfortunately. So maybe we'll just move on to image collections. I'm not sure if it will fare any better. Let's see. Looks like it did. So that's good. We'll look into that, and maybe next workshop I will come back with a solution to that issue. It's definitely something interesting to look into. But basically, we're going to be interested now in moving to Landsat, which is, as I said, the NASA USGS satellite collection. And Landsat is going to give us some pretty interesting information about surface reflectance, which is like clouds and the ice are very reflective. And this is telling us a little bit about that. So we can add a layer with specified bands from 0 to 3000. So when we look at our layers, you can see it there, L8SR. And you can use an ROI, a single point geometry, to do that. So let's put a point down here. We we can put that in there. And we now have our point, and it's added to the map. So we can sort by cloud cover and find the least cloudy image in the data set. You can see our image collections are coming out here, and the least cloudy image is stored. It takes a little while to compute because of how much data there is. We can look at these collections, and you can see it's beginning to populate for us there. This part that we're looking at over here is Navajo Nation. So we can check out Navajo Nation. It takes a long time for this one to load. I think it's because I'm so zoomed out. Hang on, real quick, I'm gonna fix my window. Sorry about that, everybody. While I was waiting for things to load, I figured I would just go fix the window because it's getting to be that time of year where the sun is coming in right through the. Yeah, you can see you can actually overlay these images and add them. So we've added this L8SR band image to the map with these three bands, B4, B3, and B2. So it's kind of an interesting thing, and we can collect these images we might be interested in, whether it's a particular date, particular cloud coverage, and so on. All right, everybody. We're coming up on about an hour now in our workshop. So if anyone has any questions, please feel free to post those in the chat. We're going to take a short 10-minute break and be back in a jiffy to finish our workshop. So see you then. All right, everybody. Well, welcome back to our session. And I was looking at the comments while we were having break, and I'm so happy to see so much help in the comments. I mean, this is why our community is so special. Is we have folks from all around the world who are experts in different things, um, contributing and helping each other. So, thank you so much. And yeah, as far as Python versus JavaScript, there is a native API, Python API for Earth Engine. So if you work better in Python, I highly recommend checking it out. But anyway, during the break, like we noticed, some of the functions, the server side functionality was seemingly deprecated from this tutorial. It's a little bit of an old one, so I went ahead and pruned our files, and we're just going to look at files now that actually work. So I won't make you do a bunch of different files that are working. So why don't we move on from our image collection segment to functions? And now in functions, we're going to use this thing called NVDI, which is a normalized difference vegetation index. It's basically a way of figuring out where there's vegetation. And I'm going to share a tab with you all, Normalized Difference Vegetation Index Wikipedia, or NDVI. And we're going to look at a plot of this value. And so we're going to try and reproduce this. You can see that where it's greenest is where there's the most vegetation on Earth. So maybe we can even find your local area and see what the NVDI value is there. You can check the caption too. Negative values correspond to water. Values close to 0 are barren areas. And low positive values are grassland or shrub. And if you have a value close to 1, then you're in a tropical rainforest. So that would be pretty cool. But regardless, let's share the NVDI, and we're actually going to compute it using a function. So we're going to get our Landsat imagery, which is the surface reflectance imagery that we were looking at in section 5. And we are going to choose a point geometry here. So this is a particular location. And yeah, we will now use spatial filtering to get the data at that particular location. We're going to get a test image, and then we're going to use our NDVI function to compute the index. And the way we do that is by taking the normalized difference, and there's actually an API method already, normalized difference, and it just requires 2 bands. And so the bands we use for NDVI are B5 and B4 bands from Landsat. And we'll just rename this layer NDVI. And when we return, what we return is the image with this additional band, this NDVI band. So whenever we apply this add NDVI function, it's going to put that on to an existing image. So we're going to test the function, and we're going to do that because we want to have some print statements if we would want to have them. If you don't, that's okay. But yeah, we're gonna add this layer by putting NDVI on our test image. So if the function works, we can then map it on to our map layer. So let's test this out first. See what we get. We're in Japan right now. Pretty cool. But it looks like our code ran just fine. So we're going to extend it to the entire collection, not just that point that we specified earlier. So let's see what we get. Takes a little while to load, but here it comes, all kinds of green. Pretty cool. You might notice that sometimes we get a really big blot of white. So in this case, unfortunately, we have some clouds. And that'll mess up our index a little bit. But you can see that the vegetation did definitely get captured. For example, by these rivers, there's less vegetation because there's water there. And you can absolutely see that with the lighter shades. Yeah, and as Indigo mentions, there's different bands. So the NDVI is calculated according to wavelengths. And so if the band is referring to a particular wavelength, you don't want to use the wrong band. So it's kind of important to keep that in mind. I'll show you an equation, actually. We want to use near infrared and the red wavelengths. So these are two different bands of color, and they could be different for different satellites. Well, going back to our Earth engine, let's move on to the next file. And we're going to reduce our image collection by actually kind of calculating here, making a calculation. So instead of using just one calculation, we're going to be finding the median, having the median there, having the max NDVI. And so that's going to be kind of useful to us. We might be able to get some more information by doing some calculations on NDVI instead of just taking the NDVI at a particular image. Takes a little bit longer for us because we're doing some calculations, but we'll see the fruits of our labor pretty soon. It's slow going, but you can see that we're getting quite a few of our layers in. And we have greenest pixel composite, which is actually giving us what is the greenest, most lush picture we could have over this region, where the NDVI is maximized in every single picture. So, or in every single pixel. So that's kind of interesting. We'll definitely be sure to take a look at that. We have the width and the NDVI max. So this will be, what are those values? And the median will just tell us a typical one. We have a few other ones as well, but I'm going to turn off a lot of these and just look at these maximum NDVI. There it is, super, super green. So you can see that. We're actually doing a calculation to find that. Pretty cool stuff. And here comes our greenest image. It looks like a forest. Really, really cool. Yeah. And, it's kind of amazing that we can get this perspective of Earth from coding, really. It's not a lot of humans in history have been able to see Earth like this. So it's kind of cool that we can. But I'm going to move on to one last file I wanted to show you all, which is for exporting your images. And you can export your images to Drive. So you just use this export.image.toDrive, and you can give it a file name, a description, and you can even specify a geometry. So it's like, I think Indigo is saying in the chat, you can calculate over a particular polygon to speed up and even to store a smaller amount. But always need to specify a scale as well. And in this case, we could just specify 30 meters for our image. Anyway, folks, so that's a little introduction into Earth Engine. And feel free to use these scripts, especially in their adapted form, so that you won't get any deprecated errors. And yeah, it can always be tricky to keep up with those things. But thank you so much for sticking through all the way to the end. And yeah, anyway, happy hacking. And I hope to see you for the next session, where we're going to dive deeper on a few of these topics. And yeah, it should be really fun tomorrow. So take care. Thank you so much for joining. And thank you also to our chatters, in particular, Indigo and Ajax, and everyone really, for putting in some of your expertise to this session. So thank you so much. Take care.